Okay, so let's solve this problem. So a rectangle of area 15 inches squared is inscribed in a circle of diameter 10 inches. So what is the dimension of the rectangle? Now, if this is your rectangle inscribed in a circle, then we have this length and the width and this diameter. So take note that diameter always passes through the center of a circle and touches 2 points in the circle. So this one is equal to 10. Now, since we have this given area, that's 15 inches squared. So formula for the area of a rectangle, that's length times the width. Then substitute this area to this formula. So 15 now is equal to length times the width. So this is the first equation. Now, on this diagram, there is a right triangle, and these are the values. So 10, length, and the width. Now, since this one is a right triangle, so we can solve this one using this Pythagorean theorem. The c squared equals a squared plus b squared. And this c is the hypotenuse, that's the longest side. So c now is equal to 10, and a and b are the remaining sides. So a is L, then w, that's b. So substitute now these values. So we have now 10 squared is equal to L squared plus w squared. Now, since 10 squared is equal to 100, so this is now our second equation. Then combine these two equations. Now we can solve this system using this substitution method. So in substitution, we need to isolate one variable. So isolate W or isolate L. So in this example, I'm going to isolate W. So using this equation, so divide both sides by L to isolate W. So W now is equal to 15 over L. Then substitute this to the second equation. So this is the second equation. Then W is 15 over L. So substitute. So that's 15 over L squared. Then simplify this equation. So distribute this exponent to numerator and denominator. So 15 squared, that's 225, and L squared. Then if an equation contains a fraction, so multiply the whole equation by the LCD or by that denominator. So multiply this by L squared, then distribute to every term. So we have now L squared times 100, L squared times L squared, and L squared times 225 over L squared. Then simplify. So this one, L squared times 100, and L squared times L squared, that's L to the power 4. So cancel this L squared. So we have this 225. Then equate this equation to 0. So transpose this 100 L squared to the right. So 0 now equals L4 minus 100 L squared plus 225. Now, since we cannot solve this quadratic equation using factoring, so we're going to use the quadratic formula. So this is the quadratic formula. Then let's have the value for A. So A is 1. So this one is A. B is negative 100. And C, that's 225. Then substitute these values to this formula. So we have negative B or negative 100 plus minus negative 100 squared minus 4AC, that's 4 times 1 times 225 over 2 times 1. Then simplify. Double negative, that's positive. And this negative 100 squared, that's 10,000. Then this negative 4 times 1 times 225. This one is 900, then over 2. Then this 10,000 minus 900, that's 9,100. Now, since the equation, that's L to the power 4, and the factors for L to the power 4, that's L squared. So therefore, this equation now, if we're going to break this one, that's L squared, that's 100 plus, and 100 minus. Then solve for L. So let's solve this one first. So square root of 9,100, that's 95.39, and this 100 plus 95.39, that's 195.39, and divide by 2, so L squared is equal to 97.70. To solve for L, so just take the square root, so L now is 9.88. And for the other equation, so that's 95.39, then subtract, that's 4.61, then divide by 2. So L squared, that's 2.31, then take the square root. So L now is 1.52. Now, there's no need to solve for the width because from these values, we can conclude that the rectangle dimension is 9.88 inches by 1.52 inches.